Good morning. I hope everyone is doing well. This is the second time that I've recorded this video. The first time was right kind of towards the end of it and my computer shut off. So not happy. So anyhow, I'm going to go through this relatively quickly. So you guys who are watching this video, you need to pay attention. And if you don't catch it the first time through, you need to go back and watch it later. Test is tomorrow, like we talked about last week. Really what you have here is you have two reviews that are almost the same. So anyhow, I'm going to go ahead and go pretty quickly through this, so pay close attention. So here we go. Negatives in a radical, we said those come out as an I. And then the 324, remember, if you're not sure whether or not it's a perfect square, try it. If I type in second x squared in my calculator and then plug 324 in, sure enough, 18 comes out. It is a perfect square. So 18i. Plus, we got 3 times the square root of negative 9. I'm going to leave the 3 alone for the time being. I'm going to let negative come out as an I. But then don't forget, 9 also has the ability to come out. It comes out as a 3. Now remember, this right here is all one term. So this is all one term. So we need to multiply all that out. And what we do when we multiply it is we get 3 times 3, which is 9i. So sure enough, 18i and 9i are like terms. So we can combine those and make it 27i. And there's my answer. Okay? Let's keep on going. Now I want you guys to notice something here, the difference between 2 and 3. On number 3, these are just right next to each other, which is indicating multiplication. But in this one, it's not. There's a plus sign here, which is indicating that you're simply combining like terms. So I showed you guys this using the vertical method, where you take the first term, negative 4 plus 7i, and then you pay real close attention to that sign. It's a plus. So what that means is none of my signs to the right will change. So this will remain negative 3, and this will remain negative 8i. So now we can simply combine these vertically, and negative 4 minus 3 is negative 7, and positive 7i minus 8i is minus 1i. Okay, that's number 2. Number 3, though, like we said, is multiplication. So we're going to use our distributive property. 1 times 4, 4. 1 times negative 2i, negative 2i. Then we're going to take positive 5i and multiply it by 4. That's positive 20i. And then lastly, positive 5 times negative 2i, or I'm sorry, positive 5i times negative 2i. Positive 5 times negative 2 is negative 10. And I times I, like we've been talking about, is I squared, which we said has what value? Negative 1. Which does what to negative 10? It makes it plus 10. So what are my like terms now? Well, I've got 4 plus 10, 14. And I've got negative 2i plus 20i, or 20i minus 2i, positive 18i. So 14 plus 18i. All right, moving on. We are ignoring 4 and 5. We're not going to do those in this test. Number 6 was way easier, I think, than we made it. A lot of us wanted to think there was something more to it, but remember, it says use the graph to find the solutions to the equations. Well, remember, how do I find solutions using a graph? I see where it crosses the x-axis. So this one crosses at negative 6, 0, and negative 4, 0. Those are my x-intercepts. Those are my solutions. So you could have written them like that as ordered pairs, or you could have put x equals bracket negative 6 and negative 4. That's indicating both of those solutions. Okay? All right, probably the thing that you guys struggled the most with recently has been what we're doing here, solving by factoring. So what we said is, first, you got to get everything on one side. So I'm going to subtract x from the 4x. I'm going to subtract 10 from the negative 10. That will allow these to cancel, and we will have isolated one side. Everything's on one side, and it equals 0. So what do we have? We got 2x squared. Positive 4x minus 1x is positive 3x. And negative 10 minus 10, those don't cancel. It becomes negative 20. So we have a trinomial here. Look at it. There is no greatest common factor. Nothing comes out of 2 and 3. And 20 doesn't have an x. So no greatest common factor. And since my a value is not 1, we said we were going to factor this using the over-under method. The over-under. So here's how we did that. We ignore the 2 here, and we write x squared plus 3x, and then we multiply 2 by negative 20, negative 40. We do that because now we can use the easy method of factoring. But to make up for that, we're going to do this under thing where we divide by 2, that a value. We're going to do that at the very end. So here we go. What times what gives me x squared? X times x. What times what gives me negative? Well, that's a positive and a negative. So they're working against each other. So we're looking for what multiplies to get 40 has a difference of 3. Multiplies to get 40 has a difference of 3. Now listen, you might just have to go to your calculator and type in a few things until you get it. The two numbers that will do that are 8 and 5. Maybe you had found them, maybe you hadn't. 8 times 5 gives me 40, and the difference between 8 and 5 is 3. So the last thing I look at is right here. The plus sign wins in the middle, so the plus sign has to go with my bigger factor, 8. So it's x plus 8, it's x minus 5. So here we are, we're almost done with the factoring. Remember, this one will divide 8 divided by 2, so that becomes x plus 4. This one will not, though, so we rewrite it as 2x minus 5. So that's the factoring. But remember, the question says solve by factoring. Well, solving by factoring means you're going to take those factors and you're going to set them equal to 0, and you're going to solve. So this one, I subtract 4. This one, I add 5, and then I divide by 2. So 5 over 2. Or you could have written 2.5. Okay? All right, number 8, let's get everything on one side. I'll leave that up there so if you weren't done writing it, you can continue seeing it. I'm going to add 4x to move it to the 6x. We'll cancel on the right and leave me with nothing. That's what I wanted. So on the left, I'm left with x squared, and then 6x plus 4x equals 10x. So if you look at this particular one, it's a binomial. But like always, the first question we should ask ourselves is there a greatest common factor? And I hope that you see that they both have at least an x in them. So we're going to pull out x. That's my greatest common factor. Now, when I pull out x, here's what it leaves me with. X squared divided by x is x. And positive 10x divided by x is plus 10. So these are my two factors. Now remember, this one is very important here because it's a variable. So we take it and we set it equal to 0. We take x plus 10 and we set it equal to 0. This one's already solved, x equals 0. But this one we need to subtract 10, so x will equal negative 10 as well. Done. Moving over, number 9. As you notice here, you have everything on one side, so we don't have to do any work there. But then you have a binomial that has no greatest common factor. Look, nothing goes into 4 and 25, nothing. So I'm going to hopefully recognize that this is a binomial that has a minus sign and 2 perfect squares, difference of squares. In fact, I taught you that this is the one time a binomial will turn into 2 binomials. And those 2 binomials are made up of what multiplies by itself to get 4x squared, 2x, and what multiplies by itself to get 25, 5. And the rule is one of these is plus and one of them is minus. So we're going to take those factors, set them equal to 0, and solve. So this one, I'm going to subtract 5 and divide by 2. So that's negative 5 divided by 2, negative 5 halves. This one I'm going to add 5 and divide by 2. So x equals positive 5 halves. And those could also be written as negative 2.5 and positive 2.5. So there's number 9. Okay? Next group is about solving by taking square roots. Remember, there's no x term in here. None. So we're going to solve this by simply isolating x squared. That's our goal. So we're going to add 1. I'm going to divide by 16. Now use your brain, guys. If you type 1 divided by 16 in your calculator, it's not a nice number. But what you should recognize is both 1 and 16 are perfect squares. So that is nice because when I take the square root of both sides, remember, we have to add what to our answer? Plus or minus. And then here, the 1 can escape as a 1. Square root of 1 is 1. And the 16 can escape as a 4. Square root of 16 is 4. So it's plus or minus 1/4. I want to say this, and I won't keep on repeating it because you should understand it. I want you to not get in the habit of thinking, well, I've got to put I on every answer. No, you don't. You know, we get in kind of a, I guess, habit of working out these problems, and the last ones we did, most of them had I in the answer. But that's because they had a negative under the square root. This one does not. So don't add something to that answer that should not be there. Okay, now moving on. Number 11. I'm going to add 7. That's 32. I'm going to take the square root of both sides. Plus or minus, we add to our answer. 32. We got to break that down because it's not a perfect square. So what's the biggest perfect square that goes into 32? 16. And it goes in there twice. So with 16 being a perfect square, it comes out as a whole number 4, but 2 gets trapped inside. So it's plus or minus 4 square root of 2. Now, as you can tell, hopefully, this is what we call an irrational number. So when I finish this problem out by adding 8 to this side, can I add 8 to that number? No. So I'm going to do very much like I did with complex numbers. I'm going to leave it as 8 plus or minus 4 square root of 2. Okay? That's how I'm going to leave it. All right, moving on to number 12. I'm going to subtract 32. That's negative 24. I'm going to divide by 2. That's negative 12. Now I'm ready to take the square root, and notice what I'm taking the square root of. A negative. So let's think about all the things that we have to do. To take the square root of both sides tells me I add a plus or minus to my answer. How did that negative escape the radical? As an I. And 12 is not a perfect square, but 4 goes in there 3 times, and 4 is a perfect square. Now don't try to break it down with 6 and 2. Neither of those are perfect squares, but 4 is. So it gets to escape as a 2, and the 3 gets trapped inside. So how do I write this? Well, I need to put the 2 in front of the I, and I need to put the square root of 3 after it. So my answer is plus or minus 2i times the square root of 3. Number 13. Please remember, I am not allowed to distribute 2 into here. Remember, multiplication comes after exponents, so we cannot do that. Please don't make that mistake. Leave it separate. Let it take care of itself. I'm going to subtract 18 first. And now here's how it can take care of itself. Divide by 2. That moves it away from x plus 5 squared, which is really what we should want to do because we're trying to get x alone. So that's negative 9. Now we're ready to take the square root of both sides. X plus 5 is left on the left side. We add plus or minus on the right. Negative comes out as an I, and the square root of 9 is 3. So plus or minus 3i. Lastly, we're going to move that 5 over by subtracting it. So it's negative 5 plus or minus 3i. Okay? All right, now this one takes a little bit of time, and it's older stuff. So I'm going to go a little fast because, again, I don't want to be working this entire time and run out. I'd say we're somewhere around 15 minutes right now, so I don't want to do that. So please notice this is in what we call vertex form, Remember, the inside is the opposite, so the vertex is at positive 3. And on the outside, it is what it is, so it's negative 32. So 3, negative 32 is my vertex. We also know our axis of symmetry then. It's x equals the x value of your vertex. So x equals 3. Now we're ready to not put it in factored form, because we've got to put it in standard form first. So here we go. We're going to take the x minus 3 and square it. So here we go. I'm going to multiply x minus 3 times x minus 3. X times x, x squared. X times negative 3, negative 3x. Then we switch it. This negative 3 times x, negative 3x. And then finally, this negative 3 times this negative 3 is positive 9. Now, generally, I combine those right here, but since I'm not there, I'm going to just do it separately. Negative 3x minus 3x turns into negative 6x. Now I'm going to distribute the 2. Not just to one thing, I'm going to distribute to all of it. So 2 times x squared, 2x squared. 2 times negative 6x, negative 12x. And 2 times positive 9, positive 18. The last thing I'm going to do is combine these like terms here. So I've got 2x squared minus 12x, and it's minus 14. Okay, so there you have it. When it's in standard form, what do we know? We know the y-intercept. The y-intercept is right here at 0, negative 14. Okay? All right, next. We're now ready to find the factored form. I want you to notice something real quickly, guys. What was the a value here? 2. What was the a value here? 2. So when I go over here and I start my factored form, I want you to think, what would be my greatest common factor that I better pull out? Well, it's the same a value I've had all along. It's a 2. So when I pull 2 out of this, it leaves me with x squared minus 6x, 12 divided by 2, minus 7. Now, you can ignore the 2. It's just not important. Why do I say it's not important? Well, because it doesn't have a variable. So here are the factors that are really important. We're going to break x squared minus 6x minus 7, which has an a value of 1. We're going to break it down into 2 binomials. So x times x gives me x squared. To multiply to get a negative, you got a positive and a negative. So we're looking for the 2 numbers that multiply to get 7, combined to get 6. So that has to be 7 and 1, right? And of course, like we've done already, since minus wins here in the middle, we're going to put minus with my bigger number and plus with my positive, or with my smaller. So there is my factored form. Let's go write it. 2 times x plus 1 times x minus 7. That's my factored form. But remember, my factors that matter, the ones that are going to give me this last thing I'm looking for, the x-intercepts, those are x plus 1, so I set it equal to 0, and x minus 7, so I set it equal to 0. This one I'm going to subtract 1, so x will equal negative 1. This one I'm going to add 7, so x will equal positive 7. So my x-intercepts are at negative 1, 0, and positive 7, 0. And there you have it. We've got them all written down and found. Okay? All right, that's a big one. Let's move along. Number 15. Again, now we're kind of on a second review. I mean, it's almost the same. The idea was just go over it, and then you work on the second part on your own. Y'all have had some time to do that, so I'm just going to go through it pretty quickly again, like I did the last one, and then we'll be done. So here I go. Leave the 3 alone, but this, remember, is all one term. So the 2 is there, let it be. The negative comes out as an I, but 147, that's not a number we're real familiar with. It's definitely not a perfect square. So let's try to find a perfect square that goes into it. 147 divided by 2 is 73.5. Don't try perfect square above that. The first perfect square below 73.5 is 64. Will 64 go into 147? No. The next one's 49. Will 49 go into 147? Yes. 49 goes into it 3 times. So the square root of 49 being a perfect square comes out as a 7. And then I can multiply that by the 2. So I'm left with 3 plus 2 times 7 is 14. The I attaches to it, and the square root of 3 at the end. So it's 3 plus 14i square root of 3. Okay, look at number 16. Again, remember, these are not multiplying because there's clearly a minus sign in between. So vertical addition, I'm going to write my 21 plus 9i down. But please remember, when that is a minus sign, it means that your signs have to change. So this becomes minus 13, and this becomes plus 2i. So 21 minus 13 is negative 8, and 9i plus 2i becomes a positive 11i. And you know what? I screwed up. 21 minus 13 is definitely not negative 8. It's just positive 8. So, whoops, sorry about that. Hopefully you have fixed it. Okay, and then number 17, remember when you have something squared, it means you're multiplying it by itself. So we have to use our distributive property. 7 times 7, 49. 7 times negative I, negative 7i. Negative I times 7, another negative 7i. And lastly, negative I times negative I. Well, negative times negative is positive, and I times I is I squared. Well, what have we said about I squared? It equals negative 1. So that's plus negative 1. Well, what does plus negative 1 mean? Well, it means minus 1. So 49 minus 1 is 48. And negative 7i minus 7i is negative 14i. And that's done. Okay? All right, we're going to skip 18, 19, and 20. I already told you that. For this one, look where it crosses the x-axis, negative 2 and 0. So either write it as ordered pairs, negative 2, 0, and 0, 0, or write it as solutions, x equals, bracket, negative 2 and 0. 2 answers. Okay? I don't care which one you do, but those are my 2 answers. All right, number 22, factor. Solve by factoring. Sorry, we got to subtract 19x. There's nothing to subtract it from, so we jam it in the middle. So here's what we're left with. 7x squared minus 19x minus 6. So that's a trinomial. No GCF. I mean, look at that. 7 and 19 are both prime. No GCF. So we're going to try the over-under. The over-under. So remember, we're going to ignore the 7 for just a bit. And we're just going to write down x squared minus 19x. And then we're going to do 7 times negative 6, which is negative 42. So now we can factor this easy style. X times x gives me x squared. To multiply to get a negative, it's 1 positive, 1 negative. So we're looking for the two numbers that multiply to get 42 have a difference of 19. And that's a pretty big difference. So that's pretty easy to find. It's 21 and 2. It's 21 and 2. So remember, the minus sign wins. So that has to go with our bigger number, the 21. And then the 2 goes here. Now remember, that's the over. We got to do the under. Meaning we've got to take both of those and divide them by that a value of 7. Now, here are my factors. Remember, we're solving by factoring. Here's my factors. This one does not break down. So we're going to rewrite it as 7x plus 2. This one, however, does break down. 21 divided by 7. So we're going to write that as x minus 3. So we take these, we set them equal to 0, and we solve. So first, we're going to subtract 2. Then we're going to divide by 7. So one of my answers is negative 2 over 7. The other one we're going to add 3. So x equals positive 3. Okay? All right, moving along. Number 23. Again, we need to move everything on one side, so we're going to subtract that 5x. These will cancel, so we'll be left with x squared minus, or plus, 3x equals 0. X squared plus 3x. So if you look at this one, it's a binomial. And like we should always ask ourselves first, does it have a greatest common factor? And here the answer is yes, it does. We can pull x out of both. So if I pull x out of x squared, I'm left with x. And if I pull x out of 3x, I'm left with plus 3. So we're going to take these two factors. We're going to set them equal to 0. Remember, the x is an important factor here because it's a variable. So one of my answers is x equals 0. And the other one, we're going to subtract 3. So x equals negative 3. And that's number 23. All right, moving on. Number 24, very much like the one that we had on the front of the first page, the 4x squared minus 25, I believe it was. This is definitely a binomial. It's all on one side. No GCF because nothing will come out of 9 and 49. But this is definitely difference of two perfect squares. That one time I was telling you that a binomial will break into two binomials. This time, what multiplies by itself to get 9x squared? 3x and 3x. What multiplies by itself to get 49? 7 and 7. And the rule is one is positive, one is negative. So when I take 3x plus 7 and set it equal to 0, and 3x minus 7 and set it equal to 0, here are the results. We're going to subtract 7 and divide by 3. So I'm just going to leave that as a fraction, negative 7/3. This one, I'm going to add 7 and divide by 3. So I'm going to leave it positive 7/3. So there is my solving by factoring. Okay? You have 6 examples of those that you can look back at if you have any troubles. And I promise you the test is going to be very similar. I've always done it that way. So please know there's no tricks to this one either. Okay, more solving by taking square roots. So these are very similar to what you had on the back of the first page with 10, 11, 12, and 13. So I'm going to go pretty fast because we've done this already. Okay, I'm going to subtract 11. 6. I'm going to divide by negative 3. That's negative 2. I'm going to take the square root of both sides. So we're going to add plus or minus to our answer because I took the square root of both sides. Negative comes out as an I. And how about that 2? Well, 2 is definitely not a perfect square, nor will a perfect square go into it. So it stays inside the radical. Done. Moving on, 26. I'm going to add 4. That equals 8. 4 plus 4. Then, because that x plus 5 is in parentheses, I'm going to get rid of that square by taking the square root. I'm going to add plus or minus to my answer. 8 is not a perfect square. However, 4 is, and it goes in there twice. So 4 being a perfect square gets to escape as a 2, and the other square root, or that other 2, gets trapped inside. So square root of 8 breaks down to 2 square root of 2. Now lastly, I'm going to move the 5 over by subtracting. And again, since we have an irrational part and you have a real part, I'm not going to combine those. I'm just going to set them up as negative 5 plus or minus 2 square root of 2. Okay? All right. Continuing on, number 7 or 27, we're going to add 7. Negative 80 plus, or negative 87 plus 7 is negative 80. Then I'm going to divide by negative 4. Negative 80 divided by negative 4, the negatives cancel, and it comes just 20. Then I'm going to take the square root. I'm going to add plus or minus to my answer. And 20 is not a perfect square, but kind of like the last one, the biggest perfect square that goes into 20 is 4. And it goes in there 5 times. So the square root of 4 becomes a whole number 2. So it equals plus or minus 2 square root of 5. And then the last one of these, we're going to subtract 8. Negative 28 minus 8 is negative 36. Oh, sorry, I forgot. I told you guys yesterday that we're changing this to a 4. It'll work out so much nicer when I divide by 4 here. So x minus 3 squared will equal negative 9. So we're going to take the square root of both sides. So x minus 3 will equal plus or minus. The negative comes out as an I, and 9 is a perfect square, so it gets to escape as a 3. All right, lastly, we're going to add that 3 over, so it's going to be 3 plus or minus 3i. Okay? Real simple. All right, last one, and we're, I think, about 30 minutes if my time was right in my what I thought I saw on the clock when I started this. So we're going to do just fine. Remember, it's in vertex form, very much like the one that we've already done is. Remember, on the inside, it's the opposite. So my vertex is at negative 4. And on the outside, it is what it is. So negative 4, negative 12. What else did we say we already know? Well, we know our axis of symmetry. X equals the x value of my vertex, negative 4. So now we're going to turn this from here into standard form. So 3 times x plus 4 times x plus 4 minus 12. We're going to distribute x times x, x squared. X times positive 4, positive 4x. Positive 4 times x, another positive 4x. And positive 4 times positive 4 is positive 16. We're going to distribute the 3. That's 3x squared plus, I'm sorry, I forgot to do one thing. I'm so sorry. We're going to combine those like terms. That 4x plus 4x becomes 8x. Now let's distribute the 3. My apologies. I was getting ahead of myself. So 3 times x squared, 3x squared. 3 times positive 8x is positive 24x. And 3 times positive 16 is positive 48. Don't forget about that minus 12. So those are my last two things to combine together right here, positive 48 minus 12. So my standard form is 3x squared plus 24x plus 36. Okay? Now remember, what is the important piece of information we take from that? Well, that is the y-intercept at 0, 36. So we got one more thing to do. Put it in factored form and then come up with my x-intercepts, which are the factors set equal to 0. So I'm going to go from standard form, 3x squared plus 24x plus 36. And remember what I just said a minute ago when we did this problem? If a has been 3 all along, won't a be 3 here as well? Won't that number I need to take out, what we call our greatest common factor, won't it also be 3? Absolutely. 3 comes out of all of these terms. It leaves me here with an x squared, which is going to make this an easy factor. Positive 24x divided by 3 is positive 8x. And then positive 36 divided by 3 is positive 12. So like I said, because that's just x squared, that's going to be an easy factor into two binomials. Remember the rule? What times what gives me x squared? X times x. What times what gives me positive? Well, it's either two positives or two negatives. This right here tells me definitely two positives. And then lastly, what multiplies to get 12 combines to get 8. Well, that's 6 and 2. So there's my factored form. Let's write it. 3 times x plus 6 times x plus 2. And then finally, what about those x-intercepts? Well, remember, we find those by taking these factors, x plus 6 and setting it equal to 0, and x plus 2 and setting it equal to 0. So I'm going to subtract 6, that's negative 6, and I'm going to subtract 2, that's negative 2. So my x-intercepts are at negative 6, 0, and negative 2, 0. Okay, so there it is, guys. there is our review. Basically, it was 2 reviews in one because the first page was very much like the second page as far as front and back goes. So again, be prepared to take a test on these concepts tomorrow. Hope that you're having a great day, and I'll see you then.